When the engineering team started the excavation of the tunnel, at one point, hidden water inside the mountain began filling the tunnel with jet pressure speed, creating a flood-like situation. The Gotthard Base Tunnel in Switzerland is often called the Mount Everest of the engineering world. With a length of 57 kilometers, it is not only the longest tunnel in the world, but also the deepest, built at a depth of 2.5 kilometers. Why had this tunnel become a necessity for all of Europe? How did the engineering team solve the problems of falling rocks, fast-flowing water, and the wind pressure that could shatter train windows? If you look closely at the map of Europe, there is a wall of mountains standing in the middle that has obstructed trade and travel for years. This wall of mountains is called the Alps. For centuries, people traveled over them through long, zigzag paths, while snow and avalanches often blocked the way. Bridges and railway tracks were built on these mountains, but for a train to climb steep hills was extremely difficult and time-consuming. Over time, another major problem arose. To grow Europe's economy and transport more goods between countries, the situation had moved far beyond these zigzag paths. The factories of North Europe and the seaports of South Europe were dependent on each other. To solve this, engineers had only two choices: either build more difficult and wider roads over the mountains, or do something that had been considered impossible for centuries. They decided not to go over the mountain, but right through the middle of it, creating a tunnel that would be the longest and deepest in the world. This mission was as terrifying in reality as it sounded simple. So far underground, where the weight of the mountain could tear a steel wall like paper, engineers knew they weren't just fighting dirt and rocks, but forces of nature never challenged before. The biggest enemy of the Gotthard Base Tunnel construction was extreme pressure. Since the excavation was happening 2,500 meters under a mountain, millions of tons of weight would constantly press against the tunnel walls. To experience this pressure, engineers first tried digging a small tunnel, but the mountain's pressure tried to force it shut. The second big challenge was extreme heat. At such depths, temperatures easily reach 50 degrees Celsius. A human cannot work for more than 15 to 20 minutes in such heat. If the cooling system failed, the tunnel could become a living grave for the workers. After pressure and heat, the most terrifying enemy was water pressure. This wasn't ordinary underground water. It was centuries-old pressure that could pierce a concrete wall like a cannonball. This was why world-renowned engineers initially said this tunnel could not be built. They claimed machines would fail and workers wouldn't survive. Additionally, the tunnels were being dug from both sides over a distance of 57 kilometers. If there was even a 1 millimeter error in alignment, both teams would be lost in the darkness of the mountain, wasting billions of dollars. But for Switzerland, this was a question of survival. Every year, thousands of trucks passed through the Alps. Pollution was rising, and the roads had reached their limits. Switzerland decided that no matter the cost, this miracle would be built. On September 27, 1992, the project was officially approved. To ensure precision, laser navigation and GPS technology were used. Giant tunnel boring machines, TBMs, were built, which were 2 stories high and 450 meters long. These machines, named Sissy, were only cutting a few meters of rock a day. This was a test of patience that would last 17 years. During the excavation, 30 million tons of debris was removed, enough to create a new mountain. Hundreds of trucks were busy day and night just removing this debris. Every day, thousands of workers descended deep into the ground, where there was no sense of day or night, no phone signal, and no fresh air. There was only the noise of machines, the damp smell of soil, and an underground world where at one time 2,600 workers lived and worked. But soon, engineers realized that their real enemy was not the length of the tunnel. As the excavation reached deep into the mountain, they faced a threat they had expected but were not fully prepared for. 2 kilometers below the ground, the mountain rocks release their heat. As the machines moved forward, the temperature began to cross limits, first 30, then 40, and eventually 50 degrees Celsius. Now, this was no longer a construction site. It had turned into an oven. In the early days of the Gotthard Base Tunnel, the condition was such that workers would be drenched in sweat within minutes of going underground. Machine operators were given shifts of only 2 to 3 hours. Otherwise, the risk of heat stroke would rise. To solve this problem, cooling pipes were installed, through which cold water was circulated from outside the tunnel. This became the first construction site in the world where the environment for workers was created first, and only then construction began. Cracks in rocks without warning, sudden collapses. This had become a daily routine. To deal with this, workers would immediately spray a concrete mixture on weak sections. In some places, precast concrete slabs were installed, and in others, steel rings were used to create an artificial skeleton. This provided support to the weak rocks from inside. Now, the problem of falling rocks was solved, but ahead, the engineers faced another danger, not solid like rocks, but liquid. Water. During boring, there came a time when a flood of water burst out from inside the mountains. Mountains don't have uniform rock types. Some are extremely hard, while others are quite soft. Just like there are reservoirs underground, water is also stored in cracks within mountains. And because this water is under immense pressure from the mountain's weight, it can reach up to 2,900 pounds per square inch, equivalent to placing the weight of a car on just 1 square inch. The only solution was to turn this water into a solid form. For this, before boring, small pipes were drilled into the rock, and freezing liquid was circulated through them. This process continued for several weeks until the water inside the mountain froze solid. Now, if the TBM drilled through it, the frozen water would behave like normal rock. After boring through these sections, concrete lining was applied, and the freezing system was turned off. Engineers also ensured that between the concrete slabs and the mountain, collection points were left for water to pass through, so it wouldn't build pressure against the tunnel walls, but instead flow out smoothly. After overcoming this final obstacle, only one moment remained, the moment when both ends of the tunnel would meet. On October 15th, 2010, the entire world's eyes were on Switzerland. Deep inside the mountain, 2,500 meters below ground, teams from both sides were separated by just a thin wall. Everyone had one question. Would 17 years of effort succeed? Or would it become a 57-kilometer-long grave worth billions of dollars? Suddenly, the joint cutter head of the TBM broke through the final wall. This moment became a historic milestone for all of Europe. When calculations were checked, there was only a half-inch difference between the two tunnel ends. This accuracy was like threading a needle from 50 kilometers away. By now, you might think that rocks and water were the biggest enemies. But in reality, the biggest enemy was the air inside the tunnel. After construction, when high-speed trains passed through the Gotthard Base Tunnel at great speed, the air inside would have no escape route. creating a shockwave that could shatter train windows. Fortunately, this problem had already been anticipated. That's why not one, but two tunnels were built. At regular intervals, connections were made between them, along with ventilation shafts, allowing the shockwave to escape. But imagine, if this invisible force hadn't been considered, 17 years of effort and billions of dollars could have been destroyed. The idea of the Gotthard Base Tunnel was first proposed in 1940, but due to engineering challenges, construction only began in 1993. It took 17 years to complete, with the hard work of 2,600 workers and a cost of $12.5 billion. The mountain above it is as tall as 3 Burj Khalifas combined. To align both tunnel ends perfectly, GPS, gyroscopes, and laser navigation were used. The tunnel is so long that its design had to account for the curvature of the Earth. The debris extracted during construction was so massive that it could form 5 Great Pyramids if shaped. But Switzerland used this material to create small artificial islands in Lake Lucerne. A single 450-meter-long TBM consumed as much electricity as 20,000 homes. At the end of this video, I want to salute the 9 hero workers who never made it out of the mountain due to accidents. A memorial has been built at the tunnel entrance in their honor, so the world never forgets the true cost of this engineering marvel.